The global fixed income market moves trillions of dollars every day. If you want to benchmark cash treasuries, the math is straightforward. You track the clean price and the coupon. But the agency mortgage-backed securities market operates on forward-settling TBA, or to-be-announced, contracts. That structural difference introduces an immediate point of friction. Every TBA price inherently embeds both future financing costs and scheduled carry. Because of this, isolating the true performance of the underlying mortgage pool is a highly complex problem. To strip out that noise and calculate precise returns, institutional practitioners rely on the JP Morgan Data Query Terminal. We are going to use this system to break down the raw mechanics of the TBA roll, build dynamic duration hedges, and ultimately extract accurate spread equivalents. Without quantitative controls at each of these steps, measuring agency MBS performance remains a speculative exercise. The baseline unit of measurement in this framework is the funded total return. The logic here is simple. You hold a long position on a specific TBA coupon and earn the overnight SOFR rate on your notional cash position. The math requires adjustment when we factor in the roll, the physical price gap between the front and back month TBA contracts. This Bloomberg roll analysis screen isolates the carry. We measure the physical roll using the immediate and forward price. The difference is the forward drop. Here, the 3.452 drop roughly equals the mortgage yield minus implied financing costs. If the collateral trades special, that implied financing rate drops below current market repo rates. The system must realize this carry incrementally. If the drop was recognized all at once in the calculation, you would see an artificial price shock on the settlement date. Instead, the model spreads that accrual out, contrasting the daily recognized return against the static period between the two settlement dates. As the settlement date approaches, the TBA contract experiences relentless time decay. The roll accrues steadily into the daily price. Practitioners pull this precise funded return data using the specific data query expression. Mastering the roll is the absolute prerequisite for isolating true price performance from scheduled carry. To judge raw collateral performance without any distortion from carry, we remove the cash component entirely and look at unfunded returns. We achieve this by anchoring our measurement to a constant metric, the 40-day forward price. The model interpolates a price line between the front and back month TBA contracts to find the 40-day mark. Because that 40-day anchor stays fixed relative to the horizon, daily roll accrual naturally falls out of the equation. The one variable that can skew this interpolation is a sharp richening in the front month contract. This briefly pushes some carry back into the price calculation before it reverts the following month. Barring that condition, the 40-day interpolation provides the ground truth for collateral value, independent of financing. Once the pure price is isolated, we can construct hedged excess returns, the institutional standard for benchmarking against cash treasuries. If an investor allocates $100 to a TBA position, they must calculate the exact treasury units needed to hedge it. Applied hedge ratios determine those treasury units, which then adjusts the total notional cash return on the treasury side. The accuracy of that entire balancing act hinges on the duration source you select. You can use OAD, which relies stiffly on standard model-generated duration. Alternatively, the empirical 20-day duration calculates the hedge based on the actual historical price moves of the TBA coupon relative to yield changes over the last 3 weeks. The third option is trader duration, which utilizes a modified relative coupon approach. Once you select the source, you can distribute that hedge across different tenors, like the 5-year or 10-year treasury. Choosing a 5-10 blend cuts the duration in half between the two tenors, while the full curve-based hedge uses partial durations across the 2, 5, 10, and 30-year marks, directly altering the tracking error of the portfolio. This data query string executes that exact logic, calculating the excess return versus the complete treasury curve. Precise duration hedging provides the mathematical proof required to verify a manager's true excess return. The final step in the process translates that excess return into a spread equivalent in basis points, calculated by dividing the return value by the spread duration. This scatter plot maps results for Fannie Mae 2s, plotting 1-month option-adjusted spread changes against spread-equivalent excess returns. Overlaying data for Fannie Mae 6s, the regression slope shifts to 0.92x, revealing how higher coupons respond differently to spread volatility. Using these spread equivalents provides institutional managers with a concrete performance metric that looking at OAS in isolation fails to capture. We mapped the TBA roll, factored out scheduled carry, constructed a dynamic hedge, and found the spread equivalent. The JP Morgan framework supplies the high-fidelity data points necessary to execute these precise cross-sector comparisons. As fixed income markets increase in complexity, relying on robust quantitative models is the only way to establish ground truth in agency MBS analytics.